Hello, this is my demo of the ID card visual inspection system. Excuse the clutter. Um, so here we have the Kinetis K60 tower system, which is a Cortex M4 microcontroller. And on top I have a proto board. And I built the cables to interface with this stepper driver board, which also carries sensor signals, and a 24-volt power supply. And this is a card carriage that can feed test cards in for the visual inspection. We want to measure this pattern. We want to measure the Y, or the yellow, magenta, and cyan intersection points. And we can get some quality, print quality metrics off of that. Here we have a stepper motor, and there's an IR sensor positioned there to detect when the card is about to get into this area here. So, I can turn on the system. The system has a shell that communicates over the serial port to the PC. So I can do things like ping, and it responds with pong. I can start a motor. You can see now the mechanism is moving, and I can stop them using command line. So, let's see. My application is basically built on two applications. One is a visual, an OpenCV application that can analyze an image and figure out the intersection points and perform the calculations. And the other part is basically an embedded control master. So it sends the commands to the embedded system to operate the motors and synchronize things like when the card's in position, it can take a picture and then activate the algorithm to do the image analysis. So let's see. So this is basically the camera setup portion. What I can do is that's a live feed from where the card would be positioned. I can start the motor manually and go ahead and feed the card in. The card stops, and we have the image there. Now, the system is messaged back, capture image, so now the software would take the photograph of this and process it. But as you can see, I'm only using a simple webcam and this fluorescent bulb, and you're seeing a lot of noise on the image. You can see those scan lines going up, and you can see that I can see the image is not very clear and not very sharp, so that's not going to produce anything useful. However, I can show you separately that, let's see, my algorithm, if I run it against an ideal image, so this is an actual just created bitmap that I imported in and ran the algorithm against. The algorithm works very well. It can identify all the corners and these 4-point clusters at each intersection point. I'm able to get sub-pixel corner numbers in here. I'm able to sort them and eventually determine the intersections of the ideal image. However, in the real world, the cameras are adding noise to the image, and so I'm not getting these good results. Future work would include evaluating new camera and lighting equipment and modifying the algorithm to work with the real world situations where noise would be part of the image.